In this homework problem, we are completing a table of values and graphing the function y equals -4 times x plus 2 quantity squared plus 8. So as always, we start by finding the vertex, which is the value of x that makes the base 0. So what plus 2 will make this equal 0? A common mistake is to think that that answer is 2. But if we look at that a little closer, 2 plus 2 would give us a base of 4. That is not our vertex. So instead, what value makes this have a base of 0? That would be -2. So if we start our solving here, or input -2, that would be -4 times -2 plus 2 squared. I'm going to move this down a little bit, plus 8. And now we just do the math. So y equals -4 times 0 squared plus 8. I'm going to put a little space here between the -4 and the power to remind myself we always evaluate the power before the product. 0 squared is 0. 4 times 0 is 0 plus 8, and that gives us an output of 8. So if we wanted to write this as an ordered pair, which is always a good idea, our input was -2, that made the base of 0, and our output was 8. -2, 8, and we can come down here, don't know where that came from, and go from 0, 0 to -2, and then up to 5, 6, 7, 8, and there's our vertex. Now, there's always a little bit of question about how to find these inputs, and it's tougher with negatives. So if you need to, grab that scientific calculator, and the 2 points to the left are going to be your input -1, your input -2, and the 2 points to the right of the parabola, or below in the table, are your input +1, input +2. So I'm just going to go through and go -2 minus 2, that's -4. So I know that is my furthest input to the left. -2 minus 1 is -3, and that starts to ascend in order, right? -4, -3, -2. You could probably guess what the next one is, but just in case, we'll do -2 plus 1, that's -1, and then -2 plus 2 is 0. So this calculator here for a reason, to just double check your math. And then looking at this, you are counting up: -4, -3, -2 in the middle, -1 and 0, and those will be these inputs down here. Looking at this table, I'm seeing that it's addition, and anytime 0 is an option, I feel like that is the better option to do. So I'm going to be substituting in -1 and 0. It doesn't matter. You could also substitute in -3 and -4, but it does usually cause you to have to deal with more negatives, which the more negatives, the more problems. So on the left, I'll substitute in x equals -1. And on the right, I'll substitute in x equals 0. Now be careful with this problem because it does have a coefficient of -4. That's where a lot of mistakes will happen, is in this step right here, by multiplying by -4. So my function is y equals -4 times x plus 2, so that's -1 plus 2 squared, and then plus 8. Barely fits in that space. So that's y equals -4 times -1 plus 2 is 1 squared plus 8. And again, I'm just going to go through and put a little bit of space here to remind myself to do the power before the product. Y equals -4 times 1 squared is 1 plus 8. -4 times 1 is -4 plus 8, and -4 plus 8 is 4. Excuse me. So again, if I wanted to put that as an ordered pair, I could show that I inputted -1 and my output was 4. Over here with 0, y equals -4 times 0 plus 2 squared plus 8. Do what's in the parentheses first. Y equals -4 times 0 plus 2 is 2 squared plus 8. And again, I'm going to put a little space just to remind myself to do that power first. Y equals -4 times 2 squared is 4 plus 8. Negative 4 times 4 is negative 16 plus 8. Negative 16 plus 8 is negative 8. And again, you can always use that scientific calculator to double check your math. Did I plug that in correctly? 0, negative 8. So I'll take both of these and put them in the table, I should say. So negative 1, 4, 0, negative 8. And I'm just going to come over here and graph those coordinates. So from 0, 0, I go to negative 1 up to 4. And then from 0, 0, I stay at 0, go down to negative 5, negative 6, negative 7, negative 8. And then if I wanted to, I could graph this part of the parabola. So I can see here, this is undergoing both a reflection and a stretch. It's stretching way longer than the parent function, 4 times longer actually. I like to then put in the axis of symmetry to show that that's what one half of my parabola looks like. So I can already predict what the other half is going to look like. So if I wanted to go in here and show, okay, the output at negative 1 was at 4, which means the output at negative 3 is also going to be at 4. These will be the same. And if the output at 0 was negative 8, then the output at negative 4 is also negative 8. This parabola should be a reflection on the other side. And some arrows on the end there. So I can come up to my table and add those outputs, 4 and negative 8. And my parabola is pretty much done, but since I have access to this scientific calculator, I might as well go in there and double check that the input of negative 3 is actually an output of 4, and the input of negative 4 is actually an output of negative 8. So negative 4 times negative 3 plus 2 squared plus 8, does that give me an output of 4? Yes, it does. And negative 4 times negative 4 plus 2 squared plus 8, does that give me an output of negative 8? It does. So I now feel pretty confident without a doubt that I have graphed my parabola for this quadratic function correctly.